One day when I was Eastman professor at Oxford in the spring of 1948, April 1948, I caught a cold. It was before the vitamin C days. I caught a cold, and after a day or two in bed reading science fiction and detective stories, I got tired of that, and I thought, why don't I discover the alpha helix? Or I thought something like that. Why don't I try to see if I can find how polypeptide chains are folded in a way compatible with all the knowledge that we have about structural chemistry, and such that they can form hydrogen bonds to hold the parts of the molecule together. I took a piece of paper, much like this piece, and I drew on it a representation of an extended polypeptide chain with the distances approximately right and the angles right, except that one angle did not have the right value. I still have that original piece of paper, by the way. This is the bond angle at the alpha carbon atom that didn't have the right value. So I folded the paper. Actually, it took several trials. I folded it along several parallel lines through the successive alpha carbon atoms. And finally, I found a way, by folding the paper, I could make this bond angle have the value 110 degrees. And I finally found a way of folding such that when I put it together, there was a NHCO bond formed by each NH group and each CO group, a hydrogen bond which held the helical structure together and had just the right dimensions. I found that this structure, which turned out, of course, to be the structure of hair and horn and fingernail and muscle, and also present in myoglobin and hemoglobin and other globular proteins, a structure named the alpha helix, had 3 6/10 residues per turn of the helix, a helical structure in which there are 3 6/10 residues per turn.